in a bottle. This is an example in your book, but they also ask you questions about it in your homework. You place a single bacterium in a bottle at 11 a.m. At 11:01, it divides into two, so we have another doubling. These two grow. At 11:02, we get 4. 11:03, we get 8. Now suppose the bacteria continues to double every minute. The bottle is full at 12 o'clock. So in 1 hour, 2 to the 60th, is when the bottle would be clear full. But the important fact is that we have a bacterial disaster on our hands because the bacteria have filled the bottle and the entire colony is doomed. So here's the questions that they ask you. The disaster occurred because it was full at 12 o'clock. When was the bottle half full? When do you think the bottle was half full? 11:59. Most people think 11:30 because that's half of the hour, but that would be a linear progression. Remember, this is an exponential. So if it's half full at 11:59, then it's completely full at noon. So question 2, imagine that you're a mathematically sophisticated bacterium. At 11:56, you recognize the disaster. You immediately jump on your soapbox and warn that unless your fellow bacteria slow their growth, the end is just 4 minutes away. Is anyone going to believe you? Well, half at 11:59, a quarter at 11:58, an eighth at 11:57. So 4 minutes, it's only going to be a 16th full. So no, I don't think anyone would listen to you because it would only be a 16th full by then. So question 3, it's 11:59. With the bottle half full, they start listening to you. They quickly start a space program, sending little bacterial spaceships out into the lab in search of new bottles. Thankfully, they discover 3 more bottles, so you have a total of 4. Working quickly, they initiate a mass migration by packing bacteria onto the spaceship and sending them to the new bottles. They successfully distribute the population among the 4 bottles just in time to avert disaster. Given now that they have 4 bottles, how much time have they gained for their civilization? Think about that. What do you think? How much time have they actually gained? Well, at 12 o'clock it's full. 12:01, 2 are full. So 12:03, all 4 of them are full. So 3 minutes. You gained yourself 3 minutes. Okay, how many bottles would the bacteria fill at the end of the 2nd hour? Well, here's our exponential equation. 1 bottle in an hour. So my initial value is 2 to the 60th. And it doubles, so R is 1. And X would be 120 minutes. 2 hours past the original. So after the end of the 2nd hour, after the original hour is what it's talking about. So we put that in the equation. 2 to the 60th. And then 1 plus 1 would be 2 to the 120. Remember, with exponents, if my base is the same, I can add them. So I get 2 to the 180, which is 1.5 times 10 to the 54. I don't even know what to name that number. Remember, trillion is 9. Billion is 9. Trillion is 12. Quadrillion is 15. So clear up to 54, I don't even know what that would be, but it's going to be a lot of bottles.